and very, very interesting. And I think we're very lucky that Damien is here today to tell us more about how we made Selenium work at Facebook. So welcome to Selenium Conf.
Thanks. OK, so hi, everyone. My name is Damien. I work in the DevTools team at Facebook. And I'm here today to talk about moving fast. So if you come and visit Facebook, you'll see this stuff everywhere. Like, it's literally everywhere. Like, move fast and break things all over the walls. It's a really strange slide to put up at a testing conference, right? We're kind of about not breaking things here. So the point of this talk is actually that moving fast for us means not being afraid to break stuff all the time. And that actually means more testing, not less. So there we go. That was the point of the talk. They gave me half an hour, so I'm going to keep talking and fill up the rest of the space. So let's kind of start with the challenges of scale. So we have a lot of users. That may come as a surprise to some of you. We have more than 1 billion people on Facebook. We crossed that threshold sometime last year. And that's kind of scary, right? Because every change you could make 1 billion people really pissed off at you. No one wants to be in that position. And that's kind of where we come into play, helping people make sure they don't break this type for 1 billion people. Now, 1 billion people is cool. But you know what's really cool, to me when I'm in tools, after all, is a hell of a lot of engineers. So this is actually a graph of how many people we have committing code to one of our repos, the PHP code base of Facebook, over time. And it kind of goes up like crazy, right? And really, our mission in DevTools is to make all of these engineers just as productive and as impactful as they could have been when it was a 50-person company, which is like not easy to do because we've long since not been a 50-person company. And, well, how well are we doing on that? Well, actually getting pretty well. So the green line is actually how many commits these people put into the code base. It's kind of a terrible measure of productivity, but it's all I have. But the point is, like, it tracks the number of engineers pretty well. So on average, our engineers are as productive, at least in terms of number of commits, as they were when it was a way smaller company. So that's kind of something that's really cool. But it does come with a bit of a challenge, though. The product is much bigger than it was. We have more products, and we have a lot more engineers. It's a lot harder to figure out if any of your changes might have unintended consequences, or I like to call it this guy. So just to clarify, we don't do that. We don't test in prod. Those billion people are not our testers. Way back when Facebook was small enough, all the engineers kind of knew each other, knew the entire code base. It was much easier for them to know whether they were at risk of breaking something and to actually test their code just manually, just try it out and make sure that everything was broken. We've long since passed that point. And obviously, otherwise, I wouldn't be here at a testing conference talking to you guys. So what I want to talk about is what do we do since we don't test in prod? And I want to start with the life of a humble little code change at Facebook. So if I want to change one line of code at Facebook, what actually happens? Well, I start off in my sandbox. I'm on my dev server. I write my code. I have a local repo with a local Git repo with some local branches. I'm working on a bunch of changes at the same time. I submit that for code review. So all the changes at Facebook are peer-reviewed. So I pick some engineers to review my code. That eventually gets accepted and lands into Trunk. We only have one development branch. We don't do feature branching or anything like that. Trunk is where all the code is. And at some point, Trunk will become a release branch, and that release will get pushed out to 1 billion people. Now, what's really important to us at Facebook and kind of pretty unique is the engineer who wrote the code, I wrote the code. I'm actually responsible for it throughout that entire process. So what does that mean? Well, first of all, it means I'm actually responsible for testing it. We have no one else that's going to write tests for my code for me. I have to write all the tests. And why do I do that? Probably not because it's fun, right? I don't just write tests for fun. I write tests because I'm actually responsible for my code when it's out in front of 1 billion users, which means that if it goes wrong and it does something terrible on the site at 3 o'clock in the morning, which is always when bad things happen, they're going to call me and wake me up. So I don't want that to happen. And so I care a lot about writing these tests. So I want to take a look at a couple of steps in this process, and kind of perversely, I'm going to start at the end, because actually how we release Facebook determines a lot of how we go about testing it. So the question is, when does Facebook go out? Right? I've written my change. When is it going to go out? And the answer to that at Facebook is really simple. It's going to go out next week. So we have a weekly release process. Every Sunday at 6 p.m. Pacific time, trunk becomes a release branch. It's completely automatic. It doesn't matter what's in trunk. We take it. We make it a release branch. And that's going to live for about a day and a half. And during that time, we're going to be dogfooding it. So all the employees are going to be using that branch when they use Facebook. And we're going to test it. And on Tuesday, that becomes Facebook. So I really don't have a lot of time to figure out, like, oh, shit, my code was broken. I need to fix it. I only have a day and a half. So trunk had better be pretty good to start with. If trunk is bad, this would not work. Now, waiting a week is a bit of a drag, so we also do other releases. So we do twice daily releases on every other day. And those I actually have to opt into. So I can say, oh, I want my change to go out today. And it will be cherry-picked into the release branch and actually released that day. That gives us even less time to test this stuff. So it's really important that trunk is good all the time. And that's where we focus most of our efforts on testing, is making sure trunk is clean. So let's take a look at the other end of that process, which is what happens at the beginning of the life of a code change in the sandbox, and particularly in code review. So this is what a code review page looks like. So I've just written my change and submitted it. This is a tool called Fabricator, by the way. It's open source. It's actually really cool. So if you're looking for a code review tool, look for Fabricator. And what you'll notice on there, really, really small, but now bigger, is there's this little comment. Someone updated the diff, and there's a little comment from a bot called trunk agent that says, hey, there's a new test failure. What the hell are you doing? Fix it before you commit this diff. So what actually happens is when I submit a change for code review, we take that code and push it out to a whole bunch of servers. And we start running our test suite on the code before it ever gets reviewed or accepted, and way before it gets into trunk. And that's kind of a really big part of how we make sure the tests are clean. Because once the code gets into trunk, it's kind of too late. Like for us, it might get released, and then it's just terrible. But we also don't want the engineers to be waiting for the test results. So it's a waste of time if someone is sitting in front of a terminal and typing like test, and then waiting 15 minutes for test to run. So code review kind of gives us some free time, because it'll take a while for a human to actually read the code and so on. And during that time, we're actually running all the tests. So that system is called Sandcastle. It actually does a couple of other nice things. There's a little link up there in the UI. If you click on that, you can actually try the UI change in a sandbox environment without having to download their code and apply it and build it and so on. You can just try it out straight from there. So it's really good for manual testers as well, just to see what the code is actually going to look like. And we also try to give people an indication of sort of the risks that's associated with that change, right? So it's one thing to say, well, your change doesn't break any tests. That's probably because there were no tests to start with, so there's nothing to break. So we actually show test coverage for every diff that gets reviewed. And so we display that on the right. There's a tiny little column on the right with blue and red lines for covered and uncovered. Now, we have absolutely no target for test coverage. So, there is no one in the org saying we should have X% of lines covered. But this is actually an indication to the reviewers that if someone's submitting a huge diff with a bunch of red lines on the right, and it's incredibly complicated, untested code, the reviewer is probably going to go dude, you need to write some tests. So that's kind of how we keep that process honest. So it's this is a really big part of how we get our tests in a good state, but it has a couple of demands on the testing infrastructure. And the first one is speed. Basically, this if this starts to take too long, it'll get in the way of people developing. People want to get their code accepted and shipped as fast as possible because they're moving on to something else. Speed is so important, it's even more important than completeness. If we can't run all the tests in a reasonable amount of time, we're just going to run the most important ones. Because we care very deeply about hitting a target of within 10 minutes of submitting a code review change, we get all the test results. And that's a really big thing because no one reviews code within 10 minutes anyway, so you never have to wait for the test results. The other thing that's very important to us is signal. So there's nothing worse, as far as I'm concerned, there would be nothing worse than having a bunch of bad failing or flaky tests in a code base. Because all that does is it gets people used to the idea that the test might be failing, and then it's no big deal, right? It just creates noise for everyone. So how do we deal with that? Well, we're very, very aggressive about dealing with failing or flaky tests. In fact, as soon as a test starts failing or becomes flaky, there's a bot that automatically assigns a task to whoever broke it. And we only give them 24 hours to fix it. After 24 hours, the test actually gets deleted. If our point of view is if they didn't care about the test enough to fix it for 24 hours, it probably wasn't that important to start with. So we get rid of it. And that kind of keeps the code base free of old tests that no one cares about anymore, because they just get automatically deleted, and no one ever has to worry about them. So the third kind of thing that's important to us with testing is, remember, like, our developers are the ones who are writing the tests. We have no one who specializes in only writing tests. So it's really important to make writing tests as familiar as possible to developers. And that means use the same language that they're using to write their own code to write the tests. We actually had our first UI testing framework at Facebook was Water. And it was never very popular within the company. And a big part of that was we're not a Ruby shop. Like, hardly anyone at Facebook writes a lot of Ruby, but we have an awful lot of people writing PHP. And making all those PHP developers switch languages was just another barrier to getting them to write tests. So what do? We switched to Webdriver, obviously. And the solution was we wrote some bindings for Webdriver in PHP. We open sourced them about 2 years ago. And that's what we're using internally. Now, before I get on to this, I'd just like to have a quick show of hands. Like, who writes PHP for a living? Not a lot of you. Who has used the PHP WebDriver bindings that Facebook has open sourced? Who has liked doing that? So we had some glowing reviews from our internal users. I had to edit some of them. For the sake of having things that are safe to put on slides, I had to edit the reviews a little bit. I'm not even going to tell you what that guy said. I'd have to blank out the entire slide. So something wasn't quite right. And what wasn't quite right? Well, if you've seen our PHP WebDriver bindings, it's an interesting design choice. It's a very, very thin API. Actually, what it does is implicitly delegates to the JSON wire protocol. So it doesn't even define the methods that you call. It just actually uses PHP magic to do that behind the scenes. Now, the great thing about that is there's probably about like 50 lines of code to the whole thing. The less good thing about it is it's incredibly difficult, as it turns out, for people to write tests directly against the JSON wire protocol. Who would have thought? It's a very low-level API. And basically, everyone was reinventing the same things over and over again in their tests and just having a very bad time with that. So what did we do? Well, I'm not good with names. So PHP WebDriver bindings 2. We basically rewrote it from scratch after Simon hitting me on the head for long enough to decide that it was worth it. And it's a completely new set of bindings. If you know and love, and you're in that very small minority of people who know and love our existing PHP bindings, sorry, but the new ones are way better. And we open sourced it, so it's been updated on GitHub today. And it's the key design choice there is that it tries, kind of surprisingly, to be like everyone else. So we looked at the Java bindings and the .NET bindings and Python and Ruby, and we tried to do the same thing. So it'll look very, very familiar to everyone who knows any of the other bindings. So I'm deliberately not going to show you a bunch of code examples of the new frameworks, because I actually want you to go and download them and try them out. Tell us what you hate. There's a billion things missing. We'll be adding them in the next few weeks. And come and help us out, basically. So github.com, Facebook, PHP WebDriver. And where's Waihan? Oh, there we go. Wave. So Waihan wrote all of them. So I'm taking credit for the work that he's done. And in fact, he's been so efficient that I put in the soon cow in the slide just in case we weren't quite ready to release them, but we actually did it over lunch. So they are actually out there. OK, So I don't want to show you a whole bunch of PHP code, but I just want to highlight one little thing that I think is pretty neat about how developers write tests, and that's integration with the main code base. So our developers have really got the message that if you want to test your code, certainly with unit tests, it kind of helps if you actually make the code testable to start with, right? And they've really got on board with that with unit tests. And we want them to do the same thing with UI testing. So let's take a look at what that looks like. And this is like a Facebook hello world. This could be a tiny snippet of code at Facebook. It's using an extension to PHP called XHP that basically lets you, which is open source as well, by the way, that lets you write HTML directly in your programs and also create new tags that are basically UI components. It's kind of cool. I encourage you to try it out. But so this just creates a link. Now, what we can do in the Facebook code base is any HTML element in our code base has a test ID attribute that we define on the base class of all of them. And that test ID attribute has absolutely no effect in production. It does nothing. But if you're rendering the page in the context of a WebDriver test, and we have magical ways of finding that out, that becomes an attribute on the element. And that's how we actually that's how we find elements on the page. And the great thing is that this constant there, like UI mylink ID, actually becomes a contract between the application code and the test code. And that's really important, because you can change it as much as you want. That constant represents the contract. And now the test code, this is the 3 lines of WebDriver test code I actually have on my slides. And this will look familiar to anyone who's seen any of the WebDriver bindings, I guess. You can now wait until some expected condition, and the condition is that there's an element located by this test ID. And the only Facebook magic in there is the by test ID method that selects on that. So it's really simple, but it actually makes the test a lot less fragile than it would be otherwise. So that's awesome. That's the story for web. That's how we use WebDriver for web. Now, I hear some of you sort of clamoring what about mobile? Well, I didn't really, but I'm sure you're all thinking it. Well, we're really good at releasing websites and doing that sort of thing. We've been doing that for a long time. So initially, we thought, well, let's do the same thing for mobile. So if you go way back to 2012, so it's a year ago. It's 7 years in dog years, and about a million years in Facebook years. If you had 2 iPhones and you put them side by side, one with a Facebook app and one with our mobile site, you'd be kind of struck at how similar they look. And that was no accident. The mobile app was basically a web view. It was rendering our mobile site with a little bit of magic to hook into native things like camera and so on. But it was essentially a web view, which was great, because we could test it with WebDriver. We could release it just with a normal mobile site and website. And that was awesome. Problem solved. Yeah. The problem wasn't quite solved. It's kind of bad when the CEO of your company calls it the biggest mistake we've ever made. So that didn't quite work out. And the problem was we never actually got the kind of performance and native feel out of the web views. It did not work out. And so we were delivering our users a really poor experience on mobile. So what did we do? We actually scrapped all of that and rewrote. We rewrote the iOS app from scratch. We scrapped the entire code base. And we went mobile first. And mobile first at Facebook means a couple of things. First of all, it means our apps are native now. No more web views. It also means we release features we design features for mobile and then port them to desktop. And finally, it also means instead of having a small mobile team that's trying to catch up with the rest of the company, all of the company now writes mobile code. If you're a Photos engineer, you own the Photos experience for mobile. And it's just spread out across the company like that. And that's just terrifying. So this is actually a graph of how many of our engineers have committed code to one of our mobile repos. There's kind of a sharp kink in that graph, right? That's the switch to mobile first. That's the switch to everyone in the company owning mobile code. It's also absolutely terrifying, because now we have so many more people writing this code. And they're not all mobile experts who spent the last few years just becoming fantastic at mobile. They're product engineers, which doesn't mean they're bad at mobile. It just means that they haven't been doing just that. So this was a big challenge. If you think back to my first slide with a number of committers, this is a challenge we faced before, right? It's just growth in engineering, this time in growth in mobile. So, well, we thought we'll address it the same way. And it really begins with a release process. So, refresher to all the way at the beginning of my talk. Some of you remember that. This was our web release process. Weekly releases and then daily cherry-picked releases. Now, you have to look at this very carefully, because if you blink, you'll miss the transition. This is our mobile release process. It's exactly the same. We switched to a time-based release process. So we ship our mobile apps every 4 weeks. And it's exactly the same process as web, just slightly stretched out over 4 weeks instead of 1 week. So we have an automated cut on Thursdays. The app will be stabilizing and dogfooding and so on for about 3.5 weeks or something, and then we go and release that. So that's kind of the same process as web, and so it has the same constraints. Master for mobile has to be clean all the time, because we're just going to have an automated branch cut, and we don't want that to be terrible. So we need to care about testing. And that brings us to UI testing for native mobile. So, well, the first thing about UI testing for native mobile, actually, the first thing is probably that it's hard, right? We all know that. It also matters. Now, this is probably too small for you to read, but that's probably a good thing. These are some of the reviews. These are reviews from Facebook users of some of our mobile apps. Fortunately, we also get much better reviews than that, because if you're sitting near the front and you can read them, they're not very polite. We get a lot of better reviews than that, but still. Apps crashing on mobile and stuff like that is a really bad experience. And unlike on web, we can't just go and fix it. Right? We have to actually rely on the users downloading the new version. And if we release 5 versions in 5 days because we keep making mistakes and shipping them crashy apps, they won't be very happy with us. So that's a bad thing. So it matters. So what do we do about it? Well, we try to apply a lot of the same ideas that we had for our regular web development to mobile, right? I mean, there's no sense in being completely different there. Starting with, remember, all of our engineers have to write tests. So we want to use the same language that they become experts in for them to write their test. That's pretty simple. We also want to do it based on Webdriver. That's kind of a given since I'm here, but we have an awful lot of infrastructure. We've built up a lot of skills and experience with Webdriver on desktop. We want to reuse as much of that as possible for mobile. And the final thing is a little bit less obvious. We don't really just have an app, right? If you have, I don't have my phone. If I had my phone, I would show it to you. We have the Facebook app. We also have a Messenger app. We have Facebook Home, which is a launch screen, home screen, and a launcher, and everything else. So we have to be able to test that whole system, not just one individual app, which means that we actually have our testing has got to work across apps, and so essentially be out of process. So what does that look like? Well, given the requirements I've talked about, it's got to look something like that, right? I mean, you've got iOS on the left, I guess, Android on the right. And on the left, you have happy iOS developers who live and breathe Objective-C, writing their test code in Objective-C, because that's what they know. On the right, we have our Android developers. They live and breathe Java code. They're going to write their tests in Java. It's pretty straightforward. Both of them will be using the respective WebDriver bindings in their language, plus whatever magic, new kinds of selectors and so on you need to have for mobile. And this needs to talk to the actual apps that we're testing somehow over the JSON wire protocol. And why does it need to do that? Well, because we have all this infrastructure that knows how to deal with JSON wire protocol, so we'd like to not throw that all away if possible. And if we dig into that a little bit more, what's kind of in the middle there? I'm going to be very coy about this, but it's easier to talk about what's at the bottom. We fortunately have accessibility and automation libraries for these devices. We have instruments on iOS, and we have UI Automated on Android. So that's great. And really all we need now is something that talks JSON wire protocol on the one hand and can deal with instruments on the back end, and something that can talk JSON wire protocol and deal with UI automator. And I've just left this as kind of a blank of a slide. And the reason being is like, from my point of view, actually, it doesn't really matter what's there, as long as it does that. And that's kind of a point of, we've seen a lot of great tools. There's Appium, there's Webdriver, and so on and so forth. If they can all agree on what that interface should be, we can actually swap them out, right? And so that's actually a very desirable property for us. OK, so a little ahead of time, but I wanted to wrap up with some lessons learned or something, and then I realized I didn't actually have that many pearls of wisdom to offer. So I'll do the standard, we're only just starting for native mobile testing. This is something that we're going to be growing a lot over the next few months. So it's a pretty exciting time, and it's a very exciting time for us to be here and sort of find out what's going on in that space. So I'm actually going to leave it with plenty of time for Q&A, but before I do, I just want to remind you all, go and download the new PHP WebDriver bindings. Tell us what you hate about them, and we'll make them better. Cool. Any questions? There are no questions. No, seriously, there really are no questions. Yes. The secret source in the mobile diagram? It's not so much secret as not entirely known at this point. We're really just starting. I was exaggerating a little bit with the secrecy there. We're not hiding it. We're just not really ready to talk about it at this point. But like I said, if you think back to that diagram, you can plug Appium in there. You can plug iOS driver in there. As long as it's something that their tests talk to using the wire protocol, and so familiar APIs to developers, it's absolutely fine. So yeah, it's more undecided than secret. Yeah.
Do you think that 4 weeks is the correct release cycle for mobile, or do you think that over time that will get shorter as your software organization gets more mature? Keeping in mind that iOS 7 is going to be automatic updates, and Android is mostly there for automatic updates. Do you guys think you can release faster, or is it going to be 4 weeks, 3 years from now?
So, sorry, I'll repeat the question. So the question is 4 weeks the right length for release cycle for mobile? And 4 weeks is actually really not a magical thing for us. We've A/B tested a bunch of different release cycle lengths, and I don't think we're stuck on 4 weeks. From the point of view of developers, we want to release as fast as possible. That will always be the drive. We want our changes to go out in front of users as soon as possible. We just have to balance that with how much time we need for dog fooding and so on. I think automatic updates for iOS and Android are definitely interesting things, but even then, there's limits on what we can do. I mean, it's still a relatively painful process if people have to constantly update their apps. It means more cold starts. It also means you're downloading all this stuff all the time. So that's kind of bad for data usage and battery and so on. So we still wouldn't want, I don't picture a world where we would want to update this 3 times a day. Even if it was transparent to the users. But yeah, I think there will always be a drive to make it shorter, and if we can, we will. I'll start with the front. Yeah.
Can you say anything more about the test ID attribute that you use and how you have it show up for Webdriver and not in prod?
OK, so the question was more about the test ID attribute. So this is really using a feature of XHP, XHP the extension to PHP for embedding HTML. It's really more than that. All these tags are actually classes in PHP code. There's a base class to them called HTML element. Literally, the test ID attribute is define an attribute in HTML element, and each one of these classes has a render method, so it knows how to render itself. In that render method, we check whether the request that came in was from a WebDriver test. And how do we tell whether it's a WebDriver test? There's a magical cookie that only works internally that can turn that on. It basically verifies the origin of a request and the cookie to see what kind of request it is. I actually don't remember what it gets rendered as. Honestly, like, and that's a, sorry? It's a CSS class, right? Yeah. But that's the point of it in a way. Like, we should never have to think about whether this is an ID or a CSS class or something, as long as there's one selector somewhere that may be as horrible as it wants to be, but no one ever has to write it. That's fine. Cool. I'll this gentleman at the back, and then yeah. No? Yeah. Right.
What exactly are you doing with iOS and Android?
For iOS and Android? Can I talk a bit about the infrastructure for iOS and Android? Not in a great deal more detail. It actually reuses most of the infrastructure we have for web. So I didn't talk too much about the infra side of it, partly because I did that last time I talked to a group of Selenium folks. But that's a whole other topic, so if you're interested in talking about infra, I will talk your ear off at a break. But yeah, for the mobile side, we try to keep it as consistent as possible with that. So really the only difference is instead of starting up a browser, you're starting up an emulator, say if you're doing emulator testing, right? That's a pretty small difference when it comes to running the test. Actually not that complicated. As long as we have something that knows how to trigger that startup and then communicate with the test over JSON wire protocol, it's really easy for us to distribute it in the same way we distribute our regular web test. Yeah.
Historically, the PHP WebDriver binding space has been a bit fragmented, and there already exist several other projects that do PHP WebDriver bindings. Did you look at those before, and what did you find lacking? What inspired you to proceed again on your own to do another PHP?
So the question is, why the hell did we go and write another set of WebDriver bindings? Don't we have plenty of those already? I'm paraphrasing a bit. That's fine. It is fragmented. Honestly, what motivated us to do that was none of them had the real design criterion that we wanted was being as close as possible to, say, the Java bindings. Why? Because, well, first of all, very mature, and the API is actually really, really lovely. But also because that makes it much easier for us to take in any new ideas that come into the Java bindings and sort of apply them there. And none of them were kind of close to that. I think the most, probably, I could be totally wrong about this, but the most, I believe the most popular would be Adam Gauch's one, which is a fork of the Facebook PHP WebDriver bindings. And so it's basically what he's done is like put all the stuff that we should have put in there but didn't, which is awesome. But it's based on the same idea of being very low level, talking directly JSON wire protocol, and it just wasn't working for us. So yeah, anyway, the hope is that when we have 5 different solutions to a problem, try to make a 6th one that is better than all of them, and we'll see how that goes. Next year, we'll probably have 12 different PHP WebDriver bindings, but this may be the last one. We'll see. Fingers crossed. Oh, yeah. Can I talk about Peaceable? Yes, I can talk about Peaceable. Peaceable is this company we acquired last year, and they had a really cool product, which was if you remember back to the web testing slide, there's this little sandcastle link on every time you do a diff, and that's the manual testing of the UI, right? You get to review the UI as well as the code. On mobile, that's incredibly painful. On mobile, right now, the situation is you go to the build page, you download the APK, or you download the app, you install it on your device, you try it out, and now you just wasted half a day. Peaceable is this technology where you can just click on a link, it opens up a VNC view in a browser, and it'll host your app somewhere on one of our servers, and you can just interact with it directly from the browser. So have the same experience as manual testing for web. Well, we are still working on that, is the status of that. We're working on it for iOS. We're also working on it for Android. We hope to have it for Android really soon. But yeah, basically, it hasn't been deployed yet at Facebook, but I'm actually very excited about that. I think it makes a huge amount of difference to people testing their apps. Cool. Yes?
Do you guys have anything for Windows phones or BlackBerry phones?
So do we have anything for Windows phones and BlackBerry phones? No, we don't. We also don't actually write the Facebook integrations for those. We work with the partners to do that. So we don't write them and we don't test them. We provide the APIs that they use to do that. Yeah. How do we achieve 10 minutes feedback on testing? 3 things: lots and lots of parallelism. Actually not running useless tests. Unfortunately, I would love to just not care about that and run everything. But when I talk to our capacity people, they say no, and then they scare me. The other thing is also just trying to get people focused on writing smaller, more focused tests. It's very easy to write a single test against Facebook that will, just by itself, run for more than 10 minutes. If you go in and go through the login flow and create pages and also you can interact with Facebook for 10 minutes, right? That test won't really tell you anything. If it fails, it'll be incredibly difficult to find out why. Instead, we want people to write tests that are very focused on one particular interaction and just do that. So the test themselves has to be fast, and we just have to have a lot of them. Cool. I think that there's one more question. Do I have time to take that? OK, just one last question. How do we do cross-browser testing? With great difficulty, I guess, like everyone else. So most of our tests run on Firefox, Chrome, and IE as our default sort of set of browsers. Most of the tests don't need any modifications for that to work. We have some tests that sadly only run on some of our platforms. But apart from that, there's really no secret sauce there. It actually just kind of works. It's kind of Webdriver helping us there. I don't know, did you have anything specific?
In the 10 minutes timeline, is it like, I'm assuming Firefox, it will be fairly quick, but on IE and other browsers, it would take some more time than Firefox, right? So how do you manage that?
More parallelism. So if we tried to run any of this at all serially, it would be horrible. Like, it would take forever. But as long as any individual test is way less than 10 minutes, technically I can throw more machines at the problem. There's a limit to that, but yeah, we do try to limit the combinations. Like, we don't want to run in every single possible combination of browser and OS and everything, because that's using up a huge amount of resources, and we actually don't get much benefit. If it works on Chrome, IE, and Firefox, it's fine. Cool. That's it for me.